Perfect. Right on time. So, hello and welcome everybody to our second installment in our webinar series, Powering the Future. This webinar series is production of, in the beginning, 3 European projects that are funded under the same topic. That was at that time hybrid electric energy storage solutions for grid support and charging infrastructure. So this was HIHELIOS, SMHYLES, and Haven. And today we are also joined by the project Stories, which is an infrastructure project that is supporting the energy community or battery community as well. And we will have more information about this later on in our webinar. I'm your host, Daniel Kiesling, and when I'm not moderating webinars, I am working for the Bavarian Research Alliance. There we support consortia that want to apply for European funding. We can do this free of charge when there are Bavarian partners in your consortium, since we are funded by the government. And in this case, I am also active for communication activities for the project SMHYLES. Now, this is our agenda for today. As you have seen, this focus of today's webinar is business model challenges for hybrid storage energy applications. And we will start with a short contribution from the Haven project. Then we will go over with a contribution from the SMHYLES, the HIHELIOS, and the Stories project. Please, if you have any questions, you can write them in the Q&A tool of this Zoom meeting. They will be collected, and we will have a Q&A session at the end of the event where we will address your questions. Hopefully, we will make all of them. If not, we will get back to you after the meeting. Please keep your microphones muted throughout the session to avoid background noises. And if you have any other questions, just write them also in the Q&A tool. Well, so we will start as announced with the Haven project, and our speaker there is Christopher Joseph Aruna, and he is the coordinator for Haven. He's technical project manager at the Brussels Research and Innovation Center for Green Technologies, and his specialty is alternative energy mobility. Or one could say also, he told me he is always interested in any projects that have sustainability at the core. So this is his area, and he is his Master of Science from the Hasselt University. Christopher, please, the floor is yours. I will stop my screen and you can start sharing yours.
Thank you very much, Daniel. Good morning, everyone. I will be presenting the Haven project. And might I ask a quick question to Daniel? How many minutes do I have for this presentation?
You have 15 minutes.
15 minutes, okay. So I'll try as much as possible to.
Yeah, I will show up. I will show up when you are close to the finish line.
All right. Okay, so I'll take this away. The Haven project is a European-funded project under the Horizon tag. The EU officers, Linda Novosdova and Brussels Research and Innovation Center for Green Tech, is the project coordinator and the manager. So before we start or go further, any further into the project, I would like to throw us back to Energy Storage 101, which is the capturing and holding of energy in reserve for later use. It could be mechanically, it could be done chemically, it could be done, there are many ways. And in this case, we'll be focusing on the storage using chemical strategies, which is using battery chemistries to store energy. Now, Haven, with that being said, Haven is basically an innovative project that leverages hybrid energy storage systems, in this case using two different battery chemistries to bring out the best for energy provision to support grids and also charging infrastructure, and will be this project basically uses will use advanced power electronics and energy management tools to ensure modularity, scalability, and cost effectiveness. Now, there are some objectives of Haven, and in this case, we'll be listing the objectives of Haven. The first objective is to demonstrate an improved HESS architecture and using next generation storage technologies and chemistries to optimize the state-of-the-art power conversion with cognitive functionalities, to develop and validate advanced control systems and management strategies for the HESS, and to develop a digital twin for the management and diagnosis of the HESS system, and of course, to access the life cycle and establish adequate critical raw material recovery plans, and also to maximize the wider uptake of the project's results during and after the project. Now, I'll go into the methodology of Haven, and there are four elements of Haven's methodology. The first one, as we had talked about earlier, it's a hybrid energy storage system, meaning that it combines two kinds of energy storage chemistries, one for high power and another one for high energy. The second element of Haven's methodology is using cognitive power electronics, in this case DC-DC converters that have cognitive functionalities. And the third is the use of a digital twin that helps to optimize the system by giving the real-time status of the hybrid energy storage system's status, and of course using an advanced energy management system. This is the concept, or the concept diagram of how Haven's methodology, the architecture of Haven's methodology, basically. In this case, we see the EMS, which is split into three levels: the high level, the medium level, and the low level. And all of these help in an advanced control of energy distribution or energy sharing from either the high energy, high power, or both. Now we'll talk about the use cases that would be demonstrating the project. And the first use case, which will be hosted by our partners, Imekar in Turkey, would be showing how the HESS, the hybrid energy storage system, supports charging infrastructure. And the objective of this use case is to evaluate how effective the HESS would be in addressing services, ancillary services like load leveling, peak shaving, and how to minimize the load variance and also reduce costs from the consumer's perspective. The second use case by our partners, Solitech in Lithuania, will be demonstrating how the hybrid energy storage system can support a multi-purpose building. In this case, the services would be load leveling and peak shaving as well. The third use case would be hosted by our partners, DTU in Denmark, which is specifically to test the frequency, how the hybrid energy storage system can support frequency fast frequency switching in this hybrid power plant, in this power plant model, basically. And this use case, interestingly, will be kicked off this month. And lastly, we'll be looking at the virtual use case that the hybrid energy storage system would also be used on. And in this case, there will be a digital twin that this virtual use case will potentially validate. The current status of Haven is at 39%, as we are in month 19. I put a month 18 stroke month 19 because we just jumped into the month of July, and we just recently rounded up work package 2. So Haven follows a 48-month work plan, and the plan revolves around 4 working phases, which is the technology development, system integration, the system demonstration, the socioeconomic assessment, and of course the outreaching strategy. I put a breakdown of how the work packages of Haven are arranged. The green indicates that the work packages are complete. In this case, work package 1 and work package 2 have been completed. Haven has recently just celebrated a milestone with the completion of the work package 2. The work package 3 would be where the cognitive power electronics, the DC-DC converters, are being developed. Work package 4 is where the batteries are developed, and work package 5 is where the HESS system is being integrated and assembled. Work package 6 would be the demos and validation of the HESS. These 4 work packages are currently are heavily in swing, and hopefully we'll be getting more results about how the HESS actually performs in the use cases. And of course, work package 7, which is the environmental and business model assessment of the HESS. The outcomes of Haven is to demonstrate how hybrid energy storage tech can have improved performance and sustainability and safety during the transport and storage, to enable a levelized cost of storage. There's a projection that storage should fall to or around 0.05 euros per kilowatt hour by 2030, and Haven is supposed to drive to that outcome. And another outcome is to increase the digitalization from design to operation, to create synergies between producers and therefore strengthen the EU battery ecosystem, and to establish multi-service approaches to energy storage so as to reduce the costs, and to promote and increase reliability and resilience of the electricity systems. So the future, based on the objectives of Haven, are three-pronged: to have more efficient HESS hybrid energy storage solutions, to have reduced costs, and to have advanced control systems that point towards a more optimized usage of the hybrid energy storage system. I'll just run through our consortium. Our consortium spans around different parts of Europe, to even Africa. And this is basically Haven in a nutshell. And you can follow us on, of course, on LinkedIn and our social media pages. Thank you very much. And I will stop my presentation here.
Okay, perfect. You have been much faster. Let me just share my screen for the next. Yeah, I mean, very ambitious project. And if you have any questions regarding the technologies, regarding the goals, or maybe even how to get into contact with the project, or if you are interested, then let us know in the chat or the Q&A tool. Then I will hand over now to the SMHYLES project. The SMHYLES project is the one that I mentioned in the introduction, where I'm also working. It is, and it was shown in the last installment, so in our first webinar session. So this talk will not be about the SMHYLES project itself, which is a hybrid combination of aqueous or salt batteries with supercapacitors in a hybrid energy storage system. Today's session will be about business case or the business stories behind SMHYLES. And for this, we have an expert here together with us. It's Francesca Romana Piccone from RINA. And she has a bachelor's degrees in economics and management from the Luis Guido Cali University in Rome, and a master's degree in administration, finance, and control from the same university. In 2025, she also obtained an executive master in sustainability strategies and change management from the 24, okay, I don't know how to pronounce this, Ore Business School.
Yes, it's
24
Ore Business School.
Yes. Okay. Thank you very much for that.
No worry. No worry.
Yes. In 2019, you worked for the Movering Consulting company in Brussels. And then from 2021 to 22, you gained experience at the Diapinis Bonomo professional company in the area of tax credits and subsidized finance. So finance and administration through and through, right? Perfect expert for this talk. And now since 2022, you have been working, or you are working at the RINA Consulting company, and you are dealing mainly with activities related to market research, analysis in the industrial sector, commercial due diligence, techno-economic feasibility analysis, and in the energy and infrastructure sector, business planning, and so on. So welcome to the session. And if you want to share your screen, you can start with your presentation.
Yes, of course.
Oh, sorry.
Okay, I don't know if you can see my screen.
Maybe I have to stop first.
Yes, we can see your screen.
Okay, perfect. Give me only 1 second. Okay, thank you, Daniel, for the introduction. As you said, this webinar will not be about the project itself, that you already know about it, but it will be focused on showing you the business potential and potential of the outcomes of the project itself. So I think we can start. Here I reported a short overview of the project, only to give you just a quick insight of the objective itself of the project. As I mentioned, SMHYLES propose novel sustainable hybrid energy storage systems based on the combination of two low CRM storage technologies. The project itself comprehends the design, the construction, the deployment, and also the demonstration of an aqueous-based HESS and a salt-based HESS, as well as a storage duration expansion. Within the SMHYLES project are developed 3 demo sites in Portugal and Germany. And obviously, the project is in the content of the energy storage market and electricity market. So for the business potential, we started mainly from an analysis of the target markets, so mainly energy storage and electricity market. These both are two growing sectors boosted by the relentless penetration of renewables. But as we know, these sectors have also many entry barriers and several limitations, mainly due to technical constraints and also regulatory framework. So our focus was to focus on this aspect and deal with the challenge presented by the market itself. The methodology we focused for the business potential analysis and the business cases for SMHYLES started from comprehensive market analysis. As I said, focused on energy storage market and electricity market. And after that, we made an assessment of the business potential of the demonstrated as solutions. So we identified different business cases that can be exploited within the SMHYLES project. Here I reported the scope of this analysis by examining the current market landscape, regulatory context, and also the potential business cases. The activities itself aim to identify pathway for the successful adoption of the hybrid energy storage technologies, mainly in new energy markets, but we also did a dedicated focus on the African markets, which will be another target market that can be exploited. And this the outcome of this analysis have been used to identify the potential of the project outcomes itself, but also it helps us to manage potential barriers. This is the first phase, as I said, the market characterization. Within this activity, we mainly consider the market sizing and the growth potential and the regulatory landscape. So for the first part, so market sizing and growth potential, we presented detailed insight into the size and expected growth of the energy storage market, and we also analyzed the overall market potential for the specific outcomes of the project, focusing obviously on the European context. For the regulatory landscape, we did a dedicated assessment and review of the most recent and also the upcoming revisions to EU energy market regulations. So we critically assess this aspect and study how these regulations could have an impact, significant or not, on the business development of the HESS systems. We noticed that, as you already know, HESS have attracted significant interest over the past decade. So it's now within an extensive research, and many projects are now focusing on this kind of technology and system, focusing on the market potential itself of the energy storage. We noticed a substantial growth within the last year. We estimate the compound annual growth rate, which is around 18% from 2024 to 2029. So this will be the annual growth rate. So what is that? it will be a very high potential also for the SMHYLE solution. As I mentioned in the previous slides, the second step of our analysis was about the identification of the potential business cases for HESS solutions developed within the SMHYLES project. This was useful to assess the potential commercial viability of the three demonstrated HESS solution. And with the help of all the consortium, we outline the most promising and most significant business scenarios that could be exploited within the project, but it could be also useful for similar project or similar project scopes. So this is not only an analysis relevant for our project, but also could be replicable for other kind of project which has a similar scope or similar technology development. Here, I briefly reported the business cases list that we validated with all the consortium. The first business case that we identified was the energy community as flexibility aggregator. The second one is energy community as an energy service company, which can offer energy management services. The third business case is prosumer engagement. The fourth one is the hybrid power plant to increase RES in island grids, since the demo site we developed within the project are island based, so they will also have to manage with additional barriers for this kind of technology. So we structure also a dedicated analysis focusing on island grids. And the last business case is the improved energy savings by self-consumption maximization due to storage extension. I also reported a very short description. So if there are any aspects that you want to analyze more or go more in deep, I reported the description of each business case identified, but unfortunately for the time we have, I don't have the time to present in deep all these business cases. Okay, here I report which were the main elements we analyzed for each of the business cases identified. We analyzed 5 key areas, what we think are the key areas to be identified when looking at the business cases. The first one is the potential services offered. The second one are the key actors involved. In this case, we focused on mainly on the role and responsibility. The third area is the primary objectives that the service offerings aim to achieve. The fourth one is the necessary technological, economic, financial, and policy-related sources to meet the business cases objectives. And the last one are the expected advantages from the proposed services. So within the project, we asked to the responsible partners of the business cases all this information in order to have a clear and comprehensive framework of the potential of each business case. We concluded our analysis also involving an in-depth research related to obstacles and barriers that could be could incur during the implementation of the business cases. We identified here 5 primary categories of obstacles that could be presented during the implementation of the business cases. So both potential but also forecast barriers. So the main categories analyzed were the regulatory and legislative barriers, which we think are one of the most important ones, since actually there are many regulations, but mostly fragmented, so it's important to analyze this aspect. We also identified barriers related to economics and market, technological barriers, social barriers, and potential organizational barriers. So this is all from my side. Obviously, if you have any other question, as Daniel said, you can ask in the chat. I think the work we did within SMHYLES project is very valuable work that could be also replicated for a similar project, or as I said, similar project scopes. So thank you very much.
Yes, perfect. Yeah, I'm unmuted. Thank you for the presentation. Yeah, I think there will be a lot. I mean, there's a lot of room for questions, because as always with the business models, the devil is in the details, and how you obtain the data and what is the basis for this. I mean, we have long discussions also in the consortium meetings about this, and I mean, it's a research project, and this is also always a big issue, right? To accompany a research project already for the exploitation phase. So, but let's see what questions we will have in the end. Now I want to, and thank you very much for your presentation.
Thank you.
Now I want to continue to our next project that was also funded under the same topic as SMHYLES and Haven, HIHELIOS, and the project is about high energy and high power hybrid battery storage solutions, a platform for multiple grid services. And I'm very happy to welcome 2 speakers for the HIHELIOS project. One is Arnaud Juliard from Energy Pool. He is there a flexibility monetization domain manager. And he has 15 years of experience in real-time control for decreasing emissions of combustion engine with modeling, simulation, and optimization skills. He worked both for automakers and automotive suppliers in France, Germany, and Spain. He has 2 years of experience on new decarbonized mobility for maritime and cable-driven lift systems. And now more than 1 year at Energy Pool working on the revenues optimization of flexibilities for electrical grids. So a very wide portfolio, I would say. And I'm excited to see what you have to say. But first, I also want to introduce the second speaker. This is Yannis Kalenteritis. He's CFO and co-founder of ROW. And there he combines his civil engineering background with his economic expertise, both a master, to develop sustainable transport solutions. So this is the focus of this company, ROW. Develop sustainable transport solutions. And he has 6 years of practical engineering experience. He is now focusing on transport innovation through being part of 7 Horizon Europe projects. And he is liaison officer for waterborne transport, advancing maritime decarbonization. And I also read, and I'm not sure if this is still holds true, you are liaison officer with the EU mission Climate Neutral and Smart Cities. So this is also very interesting in this context, and maybe we can have a chat about this also afterwards. So I think Arnaud is going to start, right? And you can share your
Good morning,
presentation
everyone.
if you like.
Good morning, everyone. I guess that I'm not the first speaker, but I will leave probably Yanis and then Yves-Marie.
Right. Okay, then Yanis. Okay, Yanis, is it still true that you are liaison officer for Climate Neutral and Smart Cities?
I am the liaison officer of Waterborne Technology Platform, which is, let's say, the highest organization drafting the research agenda of maritime in Europe.
Yes.
So I'm doing the liaison between Waterborne Technology Platform and the other organizations, and of course the EU Cities Mission.
I see. Okay, thanks for the clarification.
So I can start. Let's say to begin with, HIHELIOS is creating. No, just taking the first slide for the moment. HIHELIOS is creating a smart, flexible energy storage system that combines high power and high energy batteries, including second life ones, to deliver better performance, longer lifespan, and lower costs. And what really makes it stand out, it is its modularity, allowing it to be easily adapted and scaled for different needs. Its use of recycled and second life batteries, which makes it more sustainable and cost effective. And one more unique proposition, if I can characterize it like that, it's advanced digital tools which can analyze energy patterns, optimize system performance, and even predict future needs. And this makes the system not only more efficient, but also more profitable in the long run. We are going to deploy 4 real-world use cases in different locations inside the European area. So we want to show how the system works in practice, and of course the main objective is to keep using it even after the project ends, and thus prove the long-term value. So now you can move on the second slide, and I'd like to start bottom up, up to bottom, to be honest, and start by focusing on decoding the market, particularly in Southern Europe, before jumping straight to the solution, which in this case is the HIHELIOS outcome. I will allow my other colleagues, Yves-Marie and Arnaud, to elaborate more on that. So let's start with the big picture. Stick on the same slide. Europe is installing batteries at a record pace. Just last year, in 2024, Europe added a massive 11.9 gigawatts of new battery storage power capacity. And if someone of the audience is not familiar on how this is translated, that's enough to power millions of homes at the same time. In terms of energy stored, it was 21.1 gigawatt hours. So to democratize the buzzwords, think of that as the size of the fuel tank. And crucially, Southern Europe countries like Italy, Spain, and Greece are becoming a major driving force behind this growth. So now, where are most of the batteries going? Historically, about 60% of these batteries have been behind the meter. This means they are installed right at homes or businesses, typically alongside solar panels. Think of a big battery in your basement or office building, storing your own solar power for use at night, for example. And Italy, speaking of Southern Europe, is the clear leader here. Mostly driven by government incentives for solar power, they had installed 5.1 gigawatts by the end of 2024, which with respect to the figure I mentioned before, it's a huge chunk of Europe's total. And Spain is also seeing rapid growth too, especially in residential behind the meter cases. In 2023 alone, they added nearly 500 megawatt hours, mostly for homes. And Greece, however, was a bit slower of the mark until recently. And as you can see on this slide, Greece is now, let's say, exploding into the battery storage scene in a major way. And Greece is, let's say, a very specific example when it comes to harsh environments. In 2024, 57% of Greece's electricity came from renewables, mainly from wind and solar. This is great, but as you know, sunshine and wind aren't constant. So we urgently need big batteries to store that clean energy when it's plentiful and to release it when it's needed. To kickstart this, Greece launched a major 1 gigawatt battery tender program. Through competitive auctions, they have already awarded contracts for around 800 megawatts of large-scale grid-connected batteries. We call these front-of-the-meter projects. These are like giant battery power plants feeding directly into the national grid. There are already over 6 gigawatts of battery projects in various stages of development in Greece. To let that sink, that's 4 times the government's original 2030 target of just 1.5 gigawatts. And just a few months ago, Greece announced, and this was a bit complicated, a new rule allowing a massive 4.7 gigawatts worth of battery projects to be built, and I highlight the word, without needing any government subsidies, because the market was a bit closed. This is a huge signal for the market. It means developers can build and operate these batteries and capitalize just by participating in the energy market, which means to buying low, storing and selling high. More, let's say, following the market rules. And this fundamentally changes the business model landscape in Greece, because this was prohibited a few months ago, and this is a reform that can change the business environment. Now, Daniel, please, you can change the slide. Daniel, thank you. Okay. Finally, we can't talk about Greece's energy future without mentioning the islands. They present unique challenges and opportunities for hybrid energy storage systems. Islands often have isolated grids. They can't easily import power from the mainland. Adding loads of solar and wind, as I said before, requires storage to keep the lights on reliably and smoothly. And while the details are more technical and are for another deep dive, these island projects, let's say from my point of view, are fascinating case studies due to these demanding environments that are also require to have resilient energy work. And last slide from my side, just to take a look at some standout Greek island projects. You maybe have heard of them in the past. Tylos led the way as the first Southern European island with a battery-packed hybrid system, reaching around 80% renewable energy. Astypalia is also a case with an island which has combined solar and storage to cut, at least this was the objective, to cut diesel use by 55%. And also this is tied into a recent e-mobility project with Volkswagen to install electric vehicle chargers along the island. Chalki, a small island also in Greece, focuses on community solar and virtual net metering. And on larger islands like Crete and the Rhodes, this is, let's say, where it's a bit trickier and where the kick starts because there are, let's say some public constraints on deploying wind farms and solar panels in the ground. So for the moment, the Greek government tried to connect them with the mainland grid, but I see the future would be brighter in the next few years. So that was all from my side, and I give the stage to Arnaud or Yves Marie.
Me. So hello everyone. Just a small focus on two HIHELIOS use cases. So we have 4 use cases. One is in Norway for supporting fast charging EV installations in a country with a lot of EV. Second one is in Belgium in a business park with solar and consumption and EV, so more for self-consumption market, I would say. And the 2 use cases with less typical business case are in Tylos, as explained with Yanis. That is an island with a great advance in renewable penetration, so it's connected to Kos and Kalymnos electrical grids. And in Tylos, they have a consumption of about 300 kilowatts and a peak of 1 megawatt, but there is already 160 kilowatt of PV installed and 800 of kilowatt of wind installed. So it's a quite huge penetration of renewable in terms of power. And parts of a former project, they have installed these hybrid power stations with almost 3 megawatts of battery. So the aim of HIHELIOS is to go further and to improve still the operation of Tylos based on the past development. So the first one is on the hybrid power station operated by UNIS. So it's still operating after the European project. And the aim are to improve operational performance, to increase storage capacity to have more renewables, to add new functionalities as black start capability when there is a blackout from the big island or loss of connections, electrical connections, and to integrate also smart operation with demand response and aggregation. So the 2 aims at the end are available to increase renewable energy penetration in terms of energy and not only power, based also on the fact that there is more consumption in summer than in winter, and to improve power supply reliability for all the users, especially during operation of Tylos isolated to the other larger island grid. And the other use case in Tylos is a much smaller one, and it's at the part of the southeast part of the island. And it's to really operate a small hybrid energy storage system to powering auxiliaries of the port, the lights also, EV chargers, and to store local PV production and provide voltage support regulation in this part of the network that has some congestion issues and also stability issues. So helping renewable penetration of this part of the grid, and also permit peak shaving in consumptions, load living in consumption, and to increase or to release congestion in terms of productions. So I let the floor now to Arnaud, that will talk more on, let's say, markets and how to have business with an energy storage system.
Okay, Mike. I'm very happy to be with you this morning. Yeah. So Maria and Yanis explained very well all the challenges that we traditionally have for some hybrid energy storage that are integrated inside a complex system of smart grids. And they are summarized in this slide, especially on the left-hand side, where we are trying to, let's say, optimize the cost. In this case, we be a bit disconnected of energy markets. That's actually what we will talk about in the right hand side. So when we are not connected to the energy markets, we know what are the challenges. This is basically cost optimization that we are looking at. Trying to minimize diesel consumption has been mentioned before, of course, the maintenance costs and trying to deal with the lifespan of the assets. And of course, there's a great interest in implementing some EMS or PMS to manage all the assets in the optimal way. Okay, well. There could be also some very nice opportunities to foster hybrid energy storage investment and also, of course, renewable energy penetration, connecting to the markets, to the energy markets, in order to give services that can foster the grid balancing. Okay. And in this case, well, what we will try to reach, of course, is to maximize the revenues. So this could be a great benefit, of course, but we will see that there will be, of course, some constraints. It's not so easy to get in this category. Next slide, please. Okay, so when we connect to the market, the energy markets, and try to valorize our assets on these energy markets, there's a lot of, let's say, barriers. The first one is the regulatory. Okay, that is quite different from one country to another, from one grid to another, from one service that you pretend to give and to another. For instance, from capacity markets, energy markets, or ancillary services, the rules are very different, and you have to be very, very cautious with that, because you need certification to operate and to participate to those markets. Certification of your assets, this is quite complex and time-consuming task, and without any expert in this field, this could be a kind of disaster. This is, let's say, the preparation phase. On the other side, during the operation, actually, you have to meet your engagement. Okay, so if you don't provide the capacity that you promised, then you can get some penalty. Okay, so this is, of course, a financial aspect and will impact your final profit. So, of course, it's sandwiched. And on a very, let's say, extreme case, but not that rare, you or the operator of this asset then could see his certification cancelled. Without any certification, no operation, and that's a big loss of money. Okay, so this means that if you want to get in this field, you need a very, let's say, complex operational management that prevents any breach of breach of obligations. Okay, and you can, of course, dispatch the power as it should be in an optimal way, according on the market you are engaged in. Okay, and this means also a strategic optimization on different time horizons to maximize the returns while staying compliant. So this is not an easy thing. Okay, next step, please. So how to avoid penalties, because of course you can try to avoid to get the maximum revenues, of course, but if you earn money and then the day after you lose money, then there's absolutely no benefit. So first, certification and compliance. Okay, this is the first condition. You need for those certification to follow a long process, including a simulation, pre-simulations, and pre-preparation phase. Acceptance testing with the TSO that will require to show that you can perfectly follow power signal, for instance. You need real-time monitoring and proactive control. So that means that you should probably implement an OC, a control center, dealing with uncertainty, because you have to predict what will happen on both production and prices sides. So this is not so easy, and you have to adjust your operation in real time, and be, of course, focused on any alert that could rise. Okay. And for such operations, so we definitely recommend to use some advanced optimization tool, dealing with smart scheduling, real-time load control. And this is not an easy problem, an optimization problem, because you will have to deal with multiple assets on multiple markets and uncertainty. So be careful with the headache. Okay, I hope everything is clear. That's it for me. Thank you very much.
Thank you so much. We are a little bit over time, but I thought that this was a very interesting discussion or presentation also in the end. So I think we can learn a lot from this. So I did not want to stop you there. I did not know that Yves-Marie also joins the conversation. Otherwise, I would have introduced you as well. So let me do that now. So we have the team complete. So another speaker was Yves-Marie Bourien. He is the HIHELIOS coordinator, and he's research engineer in stationary energy storage at the Solar Technologies Department at CEA in France. And he's working for more than 15 years on stationary energy storage technologies, mainly batteries, for providing ancillary services, flexibilities, and for easing renewable integration at different grid scales, hybrid systems, microgrid, and so on. Since 15 years, he's working at the CA on several topics: performance and security testing and characterization of battery technologies, sizing and modeling of BESS, self-consumption, grid flexibilities, second life application, hybrid energy storage systems, and so on. So welcome to the discussion, Yves-Marie, and we will also hear from you maybe later during the Q&A. Now, I want to switch to our next project. I'm sorry for this, which is stories. And for this, I have a guest that probably needs no introduction, maybe, at least to the people present here. I know Stefano already from previous Horizon project, the High Flow project, which was like a predecessor of SMHYLES. And Stefano is the coordinator for the EU project Stories, an infrastructure project that provides services to battery scientists. And he's a distinguished senior fellow at the KIT in Karlsruhe. He's principal scientist at the IIT, the Austrian Institute of Technology, and member of the German Academy of Sciences Leopoldina. And his research focuses on the development of materials for high energy batteries, with a goal to create environmentally friendly and sustainable energy storage systems. And he has an impressive track record of almost 800 scientific papers and a few book chapters, several international patents. So, Stefano, without further ado, please, I'm really looking forward to your talk, and you can share your screen.
Thank you for the nice introduction, and hello everybody. So let's hope that it's gonna work like it did before. Can you see the screen?
Yes, we can see the screen. Thank you very much.
Very good. So yes, as it was said, I have the pleasure to be the coordinator of STORIES, this Storage Research Infrastructure Ecosystem. Maybe among the projects presented today, it's the oldest one. Actually, is going to end in 3 months from now. And I use these cartoons in several, okay, because it is so intuitive and so simple. More solar energy, more wind power, but actually what we need is more energy storage for sure. Because we have to consider that the energy we make use, electricity now, and also other ways in the future, more and more electricity. I mean, we really need to take care of it on the time scale going from 1 second. 1 second of lack of energy supply for the electric grid means that a country can have a blackout. Okay, and we have seen it very recently in Spain, up to next winter. How are we gonna warm up our houses next winter? Because in winter usually is where there is a lack. And this came out actually mostly from the Joint Program Energy Storage of the European Energy Research Alliance, which sees a lot of members. I don't want to go through it, but mostly in this joint program, we are addressing all, let's say, basic ways of storage. And we are realized that the electrochemical, chemical, thermal, whatever, they were not talking to each other. So each energy storage was seen as a single entity, okay, and very frequently in conflict with the other energy storage entity. And actually, in storage, we try to solve this problem by generating this research infrastructure ecosystem, let's say, in which the different ways of storing energy could talk to each other and try to find out the best solutions possible. I mean, there were about 70 institutions involved. Some of them were main partners, others were associated partners or affiliated parties, linked parties, and others participated as supplier of, for example, research facilities. So as I mentioned before, the project is going to end in 2 or 3 months, and the vision was okay. Try to facilitate and accelerate the discussion about hybrid energy storage. So in the previous 3 presentations, we have seen one possibility, which is a combination of different electrochemical energy storage, but there are also other means which are completely different. For example, if you really need energy to be delivered to prevent for the frequency regulation within like a couple of 100 milliseconds, a battery cannot do it. I'm a battery scientist, so I'm not against batteries, but the battery cannot do it because the battery management system will usually react within like 500 to 700 milliseconds. Okay, and you need something faster. On the other hand, you cannot use a battery to store the energy we will need next winter. Okay, for Europe, we estimated about 10 terawatt hours, and this would be equivalent to, I just did a small calculation, to about 3 million tons of batteries, okay, which is far more than what we produced in lithium-ion batteries so far, for example. Okay, but let's enter into the system. So this was first the main concept, okay? There is no silver bullet solution for high energy storage. We need to hybridize the energy storage in order to respond to all these questions, okay? The problems associated to the energy storage and in general to the energy in Europe. So the main objective with which we could also define as a business model of STORIES were to foster a European ecosystem of industry and research organization toward hybrid energy storage technologies. There was nothing like that 5 years ago when we started the trip. okay, to provide access to world-class material and energy storage research infrastructures. And very important, actually, the third one, to ensure the long-term sustainability of energy storage research by defining scenarios and strategic roadmaps, as well as, even more important, setting up a framework for the scientific and technical training of young researchers. Because we are really missing scientists or engineers that are not thinking about batteries or thermal storage. What we are missing are engineers that are thinking to the whole system, okay? Okay, so starting for the ecosystem, actually we have been pretty successful. We already started for a pretty large audience, but at the very end we could get about 250 members in the extended network, plus the project core participants. For example, these involve large energy companies like the Italian ENI, the oil company, the French EDF, so electric company, and many large-scale research infrastructures in Europe. And this was maybe the easiest part, to be honest, because we found a lot of interest. I mean, the presentation will be shared online. You can look at the full participants, link their parties, subcontractor, and also the external network. I don't have time to go into too many details. Second main objective was to provide access to the world-class materials and energy storage research infrastructure. And this we did. We did it through actually most of the funding, almost 50% of the funding of stories went into this. So we have been supporting both the research infrastructure as well as the engineer or scientists that wanted to make measurements or to realize experiments in this research infrastructure. There was not at the very end not much funding going to the partners themselves, but more to the external scientists and engineers as well as the research infrastructure, and this has been pretty successful. Again, we made biannual calls. At the very end, we managed to make even an extraordinary call in March 2025. So we made one more call than planned, and this was also pretty well attended calls and pretty successful in terms of results, which analysis would be presented at the final event in October in Brussels. And the last and maybe most important point, I mean, I want to talk about is to ensure the long-term sustainability of hybrid energy or energy storage in general, energy storage research in general. So defining scenarios and roadmap and strategy. This definitely is the most important. We try to understand what is going to be the energy storage in the future. Okay, so we try to define the needs for energy storage across stationary and mobile applications, because mobile application actually can support energy storage, stationary energy storage also. This should never be forgot. And identify hybrid solution that could then address the related technical challenges. So combining electrochemical, chemical, mechanical, thermal, and electrical, like flying wheels combined with superconducting materials. Okay. This roadmap is going to be published soon. Actually, I think today, maybe or Monday next week, it will be available on the Stories website. Next was strategic research and innovation agenda. And as I mentioned, it is hybrid energy storage will be more and more important at all scales. I mean, so with this RIA, we try to set directions, so identify the key research gaps and accelerate the development, drives collaboration with other entities like ATIPS, but also industry groups and research alliance, and build momentum. The RIA is actually already published and is available on this on the Stories website. It's open, obviously, to everybody, and everybody can download it. And then, in the very last case is a book that was actually is open access book that we are working on. It will be available in October. And in this book, we specifically address 17 use cases dealing with really different environments. I mean, industry, grid, off-grid, transport, buildings, but also in very different environments in Europe, because the situation in south of Europe is definitely not the same as those in the Scandinavian countries, and they require different approaches or to find the appropriate solutions. And we have involved actually leading scientists again and engineers, sometimes out of the Stories project, many times actually, out of the Stories project to contribute with their expertise to the hybridization of energy storage. I just want to spend a short time because, for example, for the hard to abate industry decarbonization, actually we have worked on a very key point, that is the production of cement. So how to make the production of cement more sustainable. And this work has been done by the students, which were selected as the best working group at the summer school last year. So that's very interesting. Also the promotion of young scientists, which is actually the final part of, let's say, the final main objective, the setting up of the framework for scientific and technical training of young researchers. We definitely work quite a lot here. We have established the mentoring program. We have the animation of this slide is a mess, so I will fix it. Okay, we have made available online academic courses on energy storage, a master program. Also, as well as we established this early stage researcher network, and I'm at the end trying to recover a little bit of time. We also organized these summer schools. The first one was in Cyprus, mostly dedicated to the Repower EU, EU and the need for energy storage. A second one was made in Rome last year at the ENI facility in Rome, mostly focusing on hybrid energy storage. And actually, the last one, which took place just a couple of weeks ago in Trondheim, so we try to cover all Europe, was focusing on the mid to long-term hybrid energy storage, where for long-term, we really mean long-term, so seasonal energy storage next winter. Okay, and mid maybe is week to a month, so very, very long-term storage. Okay, and with this, I just close my presentation, presenting the other members of the KIT coordination teams, and obviously we have a connection on all the media, the social media. And thank you for your attention.
Perfect, Stefano. Thank you for this very interesting talk, and on also the really long-lasting effects of your projects. So you mentioned the SRIA. Is this then also somehow feeding into the But4EU SRIA that is then creating the Horizon topics potentially?
Hopefully, yes. We will organize this final event in October, and we are trying to invite policymakers and so on and involve them. But if I can just make a sentence, the sentence, since we started to talk about hybrid energy storage, the hybrid energy storage started to appear in the European calls.
Yes.
Okay.
Yes. Okay, perfect. And maybe one follow-up question, because you have now this established network of research organizations, and I guess you also mentioned this, that you cross-financed studies and that were then made by this network. So how is it going to continue? If I want, as a researcher, to use this network after the project ends, is there already some outlook, contact point, a homepage that will be still active, something like this?
This is what we are defining now. I mean, I cannot anticipate too much, but we are kind of designing a Stories 2 let's say, proposal and hopefully project.
Okay. Yeah, this is always a pity with the research infrastructure projects, right? I also had one with a material characterization. It was the same story. The funding stopped, and it's really hard for these publicly funded research organizations to continue this additional effort, right? That they are not getting financed. So, okay,
Yeah.
thank you for the talk and the information. So now I want to continue with, and where is it? It's supposed to be this one. No, wrong direction. With our panel discussion. I introduced all the speakers already. I hope you're all still available. And we have a couple of questions. And I want to start with a question to Haven, actually. And it is about, I mean, in Haven, the question was, you're combining cognitive power electronics and hybrid storage for grid and EV infrastructure. The question was on the key benefits and challenges you've identified in combining high energy and high power capabilities. In addition to that, and fitting to this question, we had a question about the challenges with the business case. So the business case states the levelized cost of storage target is 5 cents per kilowatt hour by 2030. And what is the main challenge there? Also, this goes to Haven.
All right. Thank you very much. I would like to address that question because it was a very interesting question. Yes, so when presenting the Haven project, if you notice, I didn't hang on much about the business modeling because we haven't actually begun with that task and with the task associated with that work package. But I'm going to answer that question because I find it very interesting. So let me start with the first question that you asked, Daniel, about the benefits of the Haven project that we can pick out from that. So first of all, we are trying to have both storage chemistries to complement themselves. Basically, the LFP in the case of Haven uses the LFP chemistry for high energy storage and LTO for high power storage. And both of these chemistries or these technologies have their upsides and their downsides. However, in the Haven project, we try to see how we leverage the good sides of both of these chemistries to complement themselves. Now, addressing that question that was asked about the challenge of meeting the 5 cent levelized cost of storage. So the truth about the matter is that is a very, very ambitious, it's a very, very ambitious target. However, it's achievable. And I'll start with the main challenge of that LCOS target. One of it is the capex, and I'll be direct. So when you're starting off with the LTOs naturally are expensive, and it throws in a high initial capex in the project. And of course, when you're talking about new technologies, in this case, the subcomponents of the Haven project, like the DC-DC converters, the EMS, and the control systems, new technologies are always expensive. So of course, that jacks up the capex of the project as well. And when you're also talking about the cycle life of using 2 chemistries, you see that one, in this case, in the case of LFPs, LFPs have a shorter cycle life compared to LTOs. So if these systems are not properly optimized, you might have a situation where you're replacing one part before the other, and that jacks up even the OPEX as well. At some point, it's a cost thing. And how do we get to the to this kind of LCOS of 5 cents per kilowatt hour? Now, the good news here is that we've seen that although in the battery market, if you look at the trends, there's a downward curve in the reduction of the prices. The good news in this sense is that when you look at China, currently, I think in the current cost of storage for LFP, I think it's around it's between 110. It's between 110 to maybe 150 per kilowatt hour for LFP, and for LTO it's higher, but maybe between 500 euros to even 800 euros per kilowatt hour. But we see in China those trends are different. Why? Because of economies of scale. China is producing these things in mass numbers, and that's just the secret about economies of scale. If you scale up, then the prices drop. So to achieve that, we are trying to exploit one aspect of what the objective of Haven is, which is to optimize. And we are exploiting optimization because, as I stated earlier, we have a digital twin that gives you the real-time status of the state of health of the energy storage system. We have an advanced EMS that's broken down into 3 layers, which is a novelty. I think there's a paper on that currently on ground. It's broken down into high level, medium level, and a low level. And these systems, or these diagnostic systems, help to increase the cycle life of the hybrid energy storage system. And we are hoping that with exploiting the optimization part of this project, we can push this into the market and also influence the economies of scale to facilitate mass production of hybrid energy storage systems that have improved life cycles due to advanced optimization technology employed within the systems. So that's where we're hoping to exploit with the Haven project, and that's how we're hoping to address the 5 cent LCOS, levelized cost of storage, by 2030, by really exploiting the part that has to do with the system optimization using the digital twin and our advanced EMS systems. Hopefully, these technologies assist the hybrid energy storage system market, and that LCOS is achievable.
So does your EMS system then also take into account the different lifetimes of the components, that it uses the one that lasts longer more often and the one that...
Absolutely, yes? Absolutely. Okay. So at each, if you notice, there are stages of, or levels of the EMS. There is an EMS that is the low level EMS also protects the subcomponents, the power electronics, like the DC-DC converters, and increases their own performance lifetime, and also protects them from damage. There is also the medium level EMS that also allocates the power share between the batteries. This protects the batteries lifetimes. So, and of course, there is a we employed an algorithm that had to do with it puts the costs of the operation cost of the HESS system takes the operation cost of the HESS system into account. So in this case, it evaluates which is more expensive, take from the grid or take from the battery. and it says, okay, if it's more expensive to fetch from the battery due to the state of health, like, hey, it's going to make this battery not last long, increase the cost, take from the grid. So it's, and of course we have the high level EMS that factors in the remaining useful life of the HESS technology. So this is where we're planning to optimize, because the EMS is in layers. It's a very advanced state-of-the-art energy management systems, and we had a lot of wonderful engineers, and I would love to even shout out to Vincenzo Mascaro. He was one of the main brains behind that amazing piece of tech in the project. So yes, we are hoping to exploit the optimization part of Haven to achieve that LCOS by 2030.
Will it be open access in any way?
Some of it yes, some of it no.
Okay, so we will have a look out what will be available and what will be maybe commercially available in the future, right? Okay, I want to address a question that we had for the SMHYLES project. You know that the SMHYLES project was dealing with hybrid energy storage systems. Now the question was the key insights that have emerged regarding the market potential and integration into energy storage market of these hybrid energy solutions. And Francesca, maybe you can give us some insights. I mean, you already mentioned some points in your talk. Maybe you can get a little bit more specific. Hybrid energy storage systems.
Yes, Daniel.
Yes.
Thank you for the question. I try to be short due to the time. I think that the main outcomes and the main insights that also derived from our analysis can be synthesized in three main aspects. The first one is the strong market growth and demand drivers, because as I shown in the presentation, the compound annual growth rate will be to around 18% from now to 2029. So as solutions have a high potential on energy storage market. Also including the demand drivers that are increasing and are mainly related to the increased renewable energy penetration, electrification of end uses, and the need of grid flexibility. The second main outcomes, I think it can be synthesized in the HESS as a strategic enabler, because as technologies combine long duration and high power storage components, so the focus is on it's uniquely positioned to deliver a wide range of services. So this versatility enhances the value proposition in both grid connected, but also as in the case of SMHYLES, also in islanded systems. And the third main outcomes I can highlight is the importance of having validated business models for the solutions, the outcomes, because presenting the example of SMHYLES, we have three demonstrators, and across these pilot sites we analyzed which could be the potential business case, which could be the more effective, which could have the most potential also on the market. So I would like to also thank all the consortium for the effort done, but this was a really important step to assess in a clear and also quantitative way the potential of the outcomes of the project. Yes, Daniel, I don't know if you...
No, I just had a question.
Yes.
And then what you're basically saying is then that depending on the case, on the use case that you are having, and you're offering hybrid energy storage solutions, but still your business case can widely vary depending on the situation where you want to go. So you have to, each project will be new for you to have the optimal business case and then develop the numbers.
Yes, I think that the most important thing is what I highlighted also in the presentation. So to focus, to identify the main areas on which develop the business cases and on which analyze potential business cases, and also do a sort of prioritization, because in some case there could be many potential business case for the project, but only some of them would have a really high potential. So it's important to structure a qualitative and a quantitative methodology to assess in the right way the overall potential.
Okay, perfect. Thanks.
Thank you.
Let's keep it in the area of business cases. So we heard that there are certificates necessary. We heard this from the HIHELIOS project. And now the question was, what type of certificates are we talking about? Is this, for example, EU-wide? Is this a national type of situation, or all across the board? And then you were speaking about the penalty, and the question was also, who gets penalized? Is it the entity offering the technology, or could it be the entity offering the service? So do you have some insights into this question? This goes to HIHELIOS. Or no, Yanis?
I can answer the question.
Yeah.
Bouchra Chevalier here speaking from Energy Pool. To be honest, each producer of battery energy system must obtain specific certification from the TSO to participate, or to be able to participate to this electricity market. It's not enough to say, okay, I can do it. He must prove that he's capable, and the installation is capable of providing the necessary service to maintain grid stability and to comply with regulatory standards. I'm going to say which kind of certification, it depends. For example, if we want to participate to the EFRR, Automatic Frequency Restoration Reserve, we must demonstrate the capability to modulate electric power linearity within X minutes, depend of the regulation, depend of the country, to comply with daily modulation requirements, and the ability to respond to this control signal sent by the TSO. For example, in France, it's RTE, the TSO, and we must comply with the regulation and requirements written by RTE. The process takes about 6 months, and it's a heavy process. If we want to participate to the FCR, there is other requirement, is to demonstrate a minimum ability to provide activation for at least X minutes. In France, it's 15 minutes. So I'm going to say the certification depends on which service we want to provide.
Yes.
And for the penalty, usually it's for the producer, except if there is a special contract with an aggregator and we demonstrate maybe that the failure is due to the system and it's not the battery. But usually, yes, it's for the penalty, it's for the asset, so it's for the producer. And unfortunately, if we have penalty, we don't have anymore the certificate and not have anymore the right to participate to the market. I hope it's clear. as an answer.
The last sentence, if you have a penalty, the project cannot participate in the market anymore. Can you not like change some things and regain the certificate, or?
You need to repass the certificates.
Okay, but if I change my configuration and then I'm able to meet the certificate standards, then I'm able to participate again. But I need the certificate.
I'm not sure. Maybe I'm not sure. I can't be 100% sure.
Okay. Yeah, I hope this. Yeah.
That's why there's a lot of testing before getting the certificate.
Yes. Okay, I see. Okay, so this is also a lengthy process that should be considered when you are thinking about your business case. At least that's how it presents itself to me, that this is not to be neglected when you want to go into this market, right?
Absolutely
also,
not. Yes.
time-wise, let's say.
Exactly. It's a key.
Okay, I see. Well, thank you for this clarification. And
You're welcome.
yes, okay, the panelist also thanked, so the question was answered. And also to HIHELIOS, I have a more let's say technical question. The question was about okay, you're managing hybrid storage systems in remote or harsh environments, and then what specific design or operational strategies have proven most effective? Can you already have do you already have knowledge about this, or is it too early in the project? What specific design or operational strategies have proven most effective?
Yanis, you want to go on?
Yes, I can land in this issue, let's say, from a less technical perspective. It's also technical, but not in terms of hardware, of course.
Perfect.
Speaking about harsh environments, to cut through the fluff, things are simple. Drawing from, and I would like to make this point, drawing from a traditional background in structural engineering, I was never one to proceed with building an infrastructure without first consulting the client. And I believe that Mr. Stefano Passerini consolidated this message in his first slide. When we talk about harsh environments, I believe it's not just about the physical conditions. To me, there are, let's say, two dimensions. First, there are the technical and hardware-related changes that if Marie can elaborate more on that, like extreme weather, remote locations, or limited infrastructure. But equally important is the second dimension, understanding how people actually use energy in these environments. So as I recalled from my traditional past occupation, our work really focuses on this second part, starting and identifying the partners of energy use. So in remote or challenging locations, energy behavior tends to be very different from what we see in urban settings. For example, in Greek islands, it's shaped by local needs, available resources, and even cultural habits, as I mentioned in the example of Crete and the Rhodes, which are the two biggest islands in Greece. There is, let's say, some kind of NIMBYism, not in my backyard situation. So this is a kind of cultural habit that you have to understand before you have to consult the client, as I mentioned at the beginning. So by understanding this usage pattern, my friend Olivier, I believe that you are not unmuted. Olivier? Yeah, it's a friendly fire from the HIHELIOS partner, I'd say. So to close my message, by understanding these usage patterns, you can optimize how hybrid energy storage systems operate, and this can help also to improve the reliability and reduce the operational costs that are tied to the hardware and the infrastructure setting.
Yes.
I just gave you a different angle to look at it.
Perfect. I mean, we are in the, let's say, business model challenge session, and it was a technical question. So I think it's a perfect answer. This sounds to me like always this design thinking approach where you really take into account all the stakeholders involved down to the last person then using it and benefiting from your solution, right? And you have to think about really the situation, the people living there, the people using then the electricity, and how this is affecting your solution and your business case. Okay, but very good answer, and most of the time not thought of during a research project. So I think this is then a really good angle.
Exactly.
Okay, so we are already 13 minutes over the time, but I would like to continue. So if anybody else has to leave, I have seen that one person had to leave. But I would like to continue for another 10 minutes, if that's okay with all of you. I hear no objections. So because I still have a couple of questions that came here to our attention, and I would like to discuss this as well. All right, the next question goes to the Stories project, to Stefano. And I mean, we heard that you provided access through your research infrastructures. Now the question was, in hindsight now, because the project is almost completed, what type of users or research topics have most benefited from this access so far? Is there a trend? Is there anything where you can say, okay, yeah, this type of research topics has mostly benefited from this access?
Yeah. I mean, first, I would love if this was my research infrastructure, but it was,
Sure.
the European research infrastructure. Initially, at the beginning, it was mostly coming from obviously universities. I have to say the applications, because we received many applications for via proposals. But initially, they were mostly from academia, let's say. Then we also had SMEs applying, and also companies. And surprisingly, although, for example, the Italian oil company shared, they have a supercomputer, and they made it available for virtual access. Initially, it was very difficult. At the very end, now in the last two calls, for example, the extraordinary call we made was only on virtual access. So it's a mix of everything, with industry getting a little bit more interested toward the end, but it takes some time. Obviously, academia is always faster to react than other fields.
Mm-hmm. But was there a specific topic or area where you would say, was it like lithium batteries or
we can actually try to prevent or this kind of proposals. So we always wanted the proposals to have an approach to hybridization of energy storage.
Mm-hmm.
So this hybridization could have been on materials. For example, I don't know, a material that could be either used on a fuel cell or on a chemical on other kind of chemical conversion process, or in a battery, okay? Or also to a device which could take care, or which could make use of different energy storage applications, okay?
Mm-hmm.
So we really wanted to stress the hybridization concept, even more than using a high rate and a low rate battery, okay? High energy and high rate. It was more combining thermal with chemical, or with electrical, or with electrochemical.
are the research projects somewhere featured that were supported by stories, or is there some kind of how do you say a non-disclosure agreement that you cannot do that? Do you know that? Like a
I'm
list
not
of
sure.
yeah.
Yeah, these are available. There will be a full report of all the activities performed within the we call them transnational access
Yes.
or virtual access. That will be reported. Although the ownership of the results belongs to the TNA user.
Yes.
Okay,
Yes.
so companies could keep the results confidential if they wanted. Also, academia.
Yes.
I mean,
Okay, then I even have another question for you. Because you also mentioned that you are training researchers, and also the project deals with socio-technical and environmental aspects. And this is typically something that is, well, it's an add-on, but it's not really fully integrated into the curricula. Do you have a special solution for this? How is this incorporated into training and the decision-making processes?
yeah, we had actually an entire work package focusing on this subject, and we organized a couple of workshops. We are also writing a couple of white papers on the subject. I mean, definitely. There are also at the summer workshop at the summer schools for young researchers, there were presentation dedicated to this point. Okay, so
Yes.
this was definitely very important. I mean, sustainability in general, social acceptance, these are things which are extremely important for the development of a stable energy system, let's say, in
Absolutely.
Europe.
Yes,
Okay.
but do you have the feeling that it is now also reaching the students then, like during their curricula?
The students who are more and more interested in sustainability. I mean, in these concepts more than before.
Yeah.
And that's definitely important. We now need to reach actually the public to avoid the NIMBY
Absolutely.
situation, which I mean sometimes is really okay. I don't want to comment anymore on this. Okay.
It's okay.
Because we need to have a safe, stable energy system in Europe. Okay, and we definitely not, we need to solve some of these problems. Okay.
Okay, perfect. Thank you for this contribution. I have a question that goes to SMHYLES and Haven. And let's see if the panelists available can answer this or connect this. So because it says that the hybrid energy storage solutions in both projects are from different angles. One is more about the EV infrastructure, and the other one is about the grid level applications. And are there areas where your findings could complement each other? It's a very, very open question, let's say. Let's see what the discussion is bringing.
Yes, Daniel, if you want, I can answer from the economic side, and Christopher could integrate from a more technical one. I can say that from a business point of view, many complementary aspects are related to business models, because as I also said before, the key aspects to be analyzed and also to be included when considering potential and most promising business cases are could be the same, could be also compared, even though operational perspective is different, but the aspects to be analyzed and to be studied could be comparable. So I think that this is an important outcome of the analysis, and also useful to bring a sort of unique methodology or unique approach also for other projects, not only for SMHYLES, but in this case also for Evan, that as I understood, Christopher and all the consortium of the project haven't started yet the work package related to business models. So this could be surely also helpful and replicable in relation to the approach to be adopted. And I can also say that from a more regulatory and policy point of view, the outcomes of the analysis conducted within SMHYLES could be also applied to Heaven project, but also other projects in this market context, because many regulations I can say we can split regulatory framework in a more generic level, and this could be useful not only for SMHYLES but all the projects that are operative within this market context, and then the more specific policy aspects that obviously are based on the specification of the project and specific operational perspective. But I think that also this one, the regulatory framework and policy policy contexts could be highly complementary within the two projects and also many other projects.
Okay. Christopher, do you want to add something, or?
Yes, I can just add to complement what Francesca has
said. You're a little quiet, low volume.
Sorry, I took out my headphones. Yes, to complement what Francesca had said, I think where Haven and SMHYLES meet in the middle, and not just Haven and SMHYLES, Haven and all projects that have to do with hybrid energy storage, is reduction of costs. We are out here trying to get efficient with a lot of systems. Haven is trying to improve the efficiency of the HESS system by using more pinpointed control systems, cognitive power electronics, energy management systems. The point where we are all meeting at is to have costs, operational, first of all, from the capital costs, to have it reduced, and to also have even operational costs reduced. So I think this is where Haven is meeting in the middle with all hybrid energy storage solutions from the point of cost. I'll keep it short.
Okay, perfect. So then my question would be, when is the perfect time for a combined workshop with all three projects regarding costs and business regulations planning?
I think we will have to have gone a little bit knee deep in the work package that has to do with business modeling. So I wouldn't just be giving you simulation-based responses or scientific conceptual responses. It would be nice to actually give you firm results from the project itself, and we'll have to go knee deep into the.
So 1 year, 1.5 years.
About that.
Okay.
about that.
we will have a dedicated workshop on this. I'm quite sure with all the project owners. Thank you for the discussion and for the answers. I have another question for HIHELIOS, but it's about the business viability of the business models. But I think I want to skip this one because we also already had this input that the business models are very specific. That you have to use a case-by-case basis, that you need to get the certifications and so on. So this cannot be answered, I guess, in a more broad answer. So I want to skip this. Also, given the time, it's almost 12. Everybody's eager to have lunch, I guess. So at least here it's 12. I don't know from where you are joining. Thank you so much for your participation. Thank you for this lively discussion, for your inputs and the preparation of your slides. And I want to say, please keep your eyes open for the upcoming webinars. We haven't settled for a topic yet for the third installment of our webinars, but it will be during the end of this year. For sure, there will be another webinar with the projects, and let's see what it will be about. And just go to our LinkedIn pages. There you will get the information, or to the home pages. Okay, that's it from my side. I want to wish you more appetit, let's say. And thanks again for everything. Bye, everyone.
Thank you, Daniel. Bye, everyone.
Thank you
very
all.
much.
Bye.
Bye, everyone.
Thank you.